Good afternoon, everyone. I hope I am audible. Hello. Am I audible? Hello. For the question in the first class, I think we had a lot of network issues. So let me just discuss the from the beginning in short, like what was our question in this class? What was our question? Here in this question, we had a 6 into 6 panel which we have to design. The internal columns were 500 mm in diameter. It is circular column, and the column the head diameter is 1000 here. The story height was 4 meter, and the design the flat slab with drop and column head. In the previous question, we had not done that. We had done the design without drop and without column head. This time we are going to design with drop and with column head. We have to take the life load to be 4 kilonewton per meter square given in the question. Assume floor finish to be 2.7 Newton per mm square. The dead load, this floor finish dead load is also given to us. We have to use M20 concrete and Fe415 grade of steel. Okay, so what we had done at the very beginning, we had to calculate this thing, the depth of the slab. So for that, these are the things which were given in the question. We know how to calculate the depth. We have L by D ratio for continuous is 26. We know this one. L by D ratio is 26. Here it is little mistake. Okay, L by D is 26 into modification factor. We know what is modification factor from IS code. Then we have the overall depth. We had assumed it to be 200 mm for the overall depth of the slab. Then the depth of the drop must be what? 25% more than the depth of the slab. Okay, so 25% of the 200 is how much? 50. So 200 plus 50 we will do, that is 250. That is the depth of the drop from the top. If we have, okay, if we draw, I show you here. This, if I show you by line method, okay. So suppose this is your this one is your slab top part. Okay, this one, this is your drop. Okay, then we have one small thickness. Okay, we will provide a small thickness of 50 mm here, and then we will have this column head, this one. This is your column. Okay, similarly in this side also you can do. If this is your column, this is your column head, and we have a small 50 mm depth thickness we provide. Why? Because, okay, so this is your drop. So if we see, this one was 200 mm, and this portion which is your drop, this one here, it is 50, because 25% more of this slab, so slab overall thickness we had taken it to be 200, but with the drop, which is should be 25% more, that means if 25% more of this, that means from here to here just 250. So it is 250 effective depth, or it, sorry, the depth of the drop from this portion from here, it will be how much now? 250. So we know our drop is how much? 50. Now we again provide a small thickness here of 50 mm again. Why? Because since this is circular, our column head is circular, this one. Okay, so it should not connect to the drop with a sharp edge. So we will provide a small thickness here drop, such that this is not connecting, that means it doesn't has a sharp edge connecting the drop, your column head. Okay, that's why we provide a small thickness here. So now if we see this one, this is given to us, our this line, that means this is given to be how much? This one, this is given to be, and how much is this? This is given to be, if we change. Okay, so we know what is our, this column head thickness, sorry, the column head diameter is given to us in the question, which was 1000 mm, and we have our column was how much? Our column was 500 mm, 500. Okay, so this is the, you see here, this is the slab, flat slab with the drop, this one, and a small drop again here. Why? To such that this doesn't have a sharp edge and connect the drop. Then we have a column head, and then we had this column here, 500 mm column, head is 1000. So here if you see now, this was your column with drop, column head, and your slab. Now we are considering this one I have showed you here. Now the effective depth of the drop is how much? Considering the 10 mm dia bars and 220 mm clear cover, we get how much? 250 minus the half of the diameter of the bar, and that means 5 mm, minus 20, we will get 225 is the overall effective depth of the slab with the drop total. Okay, so we know what we have to calculate. Our column strip 3000 we had calculated our middle strip 3000. Okay, so, and the size of the a drop, this is not depth, okay, this is drop. This is supposed to be drop. Okay, so the size of the drop is how much? 3000. This 3000, 3000 into 3000, 3000 into 3000 into 250. So now if we move down, this everything will go. So if we go down, we can go down like this. Press the right, press the right arrow key to select the option. Press the save and options. Whatever. So if we remove all this now, you have an idea now how much it is. 250 drop, 25% more since of the thickness of the slab. So this is the thing. Okay, now if we go below for the calculation of the load, see here we will have how much the self weight of the column is 3 into 3. This is the self weight of the drop. 3000 into 3000 into 0.25, which is the 250, the thickness of the overall drop from the top. Okay, now, and this is the total panel weight, the self weight of the thing slab, which is 6 into 6 minus, since we already have calculated here the dead load of this. So sorry, the portion this have to be removed since we have already calculated this dead load. So minus 3 into 3 of the drop is removed into our 200 depth of the slab, the plain slab. So into the unit weight of concrete divided by our, this is 36. Okay, here 1 6 is missing. This is 36. Okay, so 25 by 36. Why 36? Because it is a 6 into 6 panel and we are performing per unit. We are calculating per unit panel for the per unit panel. Okay, so then what we got? We got our self weight of the slabs total, how much? 5.3125 kilonewton per meter square, and the life load was given to us in our question, 4 kilonewton per meter square, and also the dead load of the floor finish was given to us for this one, 2.7 kilonewton per meter square, which will give us our total dead load and total life load calculation. All this together will give you your how much? 12 kilonewton per meter square. So the factored load will be how much? 1.5 into 12, which will be 18 kilonewton per meter square. So this was your calculation of the loads. First step was to calculate the depth. How you calculate the depth? The calculate the depth when we have a drop, then we have to calculate the depth of the drop also, which is 25% more than the depth of the slab. Now the next one was, after that was the calculation of the column strip. Why column strip we had calculated? Because we don't know the size of the drop. So to calculate this size of the drop, which we will require to calculate the depth of, sorry, the load calculation, for the load calculation, so therefore we have to know the size of the drop also. So this is drop. So to calculate this drop, we have to load of this drop self weight, we have to know the size. So to know the size, you have to know the column strip, width of the column strip. Why? Because your drop is always equal to the size of your this thing, the column strip. Okay, when you have a column strip around the column, then that is nothing but that much size of drop is given to you on the column. Okay, so that's why we have to calculate the column strip width and the middle strip width such that we know the size of the this thing, size of the drop. So with the help of the size of the drop, again we'll calculate the load calculations can be done. So we will calculate this when we have a column drop. But when we do not have a column drop, we have simple flat slabs, then what we do, we calculate the depths, we calculate the loads, and then we calculate the stiffness, etc. So but here in this case, the uh, calculation of the column strip and the middle strip is in the second step itself. Why? Because that will help us in calculation of this third step, etc. Now when we go to the next step, what is our next step? Our next step is to calculate the stiffness and the alpha c. Like earlier we had calculated the stiffness and the alpha c. Okay, I have to go down. So now if we calculate the stiffness, okay, what will happen? We know our alpha c is how much? Alpha c is kc by ks. Kc is the stiffness of your column. We have the ks is how much? Ks is the stiffness of your slabs. Okay, so this one, stiffness of the column, stiffness of the slab. We know it is how much? 4EI by L for the slab. Here 4EI by L. L we know it is 6000 for, since we don't have this time the longer span and the shorter span, both side it is same. It is a square panel, slab panel. So that means this is only your L. So I is how much for this slab? It is BDQ by 12. You know your BDQ. B is 6000 because both side it is same, 6000, 6000. So this is only your B. This is your B. This is your D, the depth of the slab with the drop. Okay, BDQ by 12. So we got our stiffness to be this much of the slab, 5.2 into 10 to the power 6 E. Now what is the stiffness of the column? Column was circular column, 500 mm. In the question it was given. So 4EI by L will be how much? L was given to be 4000. The length of the column was given because it was mentioned that the story height is 4 meter. So that means nothing but your column height is this much. Okay, so what is your I? I for the circular column will be BD pi d4 by 64. We know that D was our diameter 564. You know, so we got our KC also 3.1 into 10 to the power 6 epsilon. So we can find out our alpha C value. Alpha C is summation of Kc by Ks. So we got our Kc by S, that means this much, which is alpha C calculated is 0.589. Now in the early previous question we used to do what? We used to calculate the stiffness, and then we used to check whether uh, there is requirement of correction or not. Yes, so check for pattern loading was done. If it was not so, we had to calculate the alpha C minimum. Okay, this one we used to follow this table. I think maybe this is not downloaded properly now due to network issue. So this table we were using. 56 page number, alpha C minimum we used to calculate by dead load, live load to dead load ratio, then L2 by L1 ratio, and the alpha C minimum we used to calculate from this. So, but we have calculated the alpha C. Now let us check what is our check for pattern loading. We used to calculate live load to dead load ratio. If it would have been greater than zero point 0.5, then there would be correction required, and so we would find calculate the alpha C minimum. But here we see that 0 your live load to dead load ratio is equal to 0.5. That means which is less than or equal to 0.5. So no check or correction is required here. Okay. Earlier in the previous question we have seen that it was less than it was greater than zero point 0.5, so there was correction required, and we had calculated alpha c minimum, so that to check whether it was the correction was along the longer direction or along the shorter direction. But in this simple question, we have normal, both sides same, we don't have any longer and shorter span, as well as there is no correction also required, as we checked in the step number 5. So now next what we will calculate is, we will calculate the moment, and you know your moment, this one, we know our moment is what, the shall be m naught is equal to w ln by 8, where your m naught is the total moment, your w is the design load on an area L2 and Ln. Then we have what is our Ln. Ln is the clear span extending from face to face of the columns, capitals, brackets, or walls. Okay, and L1 is what, length of the span in the direction of mu. This L1 L2 you know, but in this particular question we don't need any L1 L2 because the L1 and L2 both are same. So what is our W L2 ln square? Because our W was what? W was W into L2 into ln. Okay. So we can calculate this. Now, one more thing. To calculate the ln, because your ln was what? Ln is this face-to-face distance from the column. So what we'll do is that we will find out the square size of the column. Our column was how much? Actually, our column was given to be, our column height was the diameter of the column head was how much? 1000 mm. Diameter of the column head was 1000 mm. So when we check what is our ln, see here, this is your panel, this is your square panel. Okay, this is your column strip, this is your column strip, this is your column strip, right? Now what is your column? You have to have a column head. This was the size of the, this is your this thing, column strip, and which is nothing but equal to the drop, because we provide the drop, size of the drop is equal to the size of the column strip. So when you have this, this is your column, this is your column head, column head, column head, column head. So, but this were circular, your column head was circular. So what we do to know the face to face ln value, what we do, we will change this square size of the column, we will change the circular column, it was column head was given, which was 1000 mm, so we are going to convert that in square size, this square size, this one. Okay, so what we can do, root over pi d square by 4, that area we have con- converted it in square. So pi d square by 4, and d is how much? Our 1000 for the head. So it gives us to be 880 mm. Okay, that means, now again one more thing, if I show you, Here is your column somewhere. Sorry, I cannot draw. Maybe I'll not be able to draw. Right? Whatever. I'll draw a screen. Okay. So we have our circular column here, right? So we are having our circular columns here. These are your circular columns. If you see the top view, it is like this. So these are your circular columns. Circular columns, right? So this total distance, if you see this center to center of the column, this one, from this center, this one, from the center, we know how much this is. This is how much? 6,000. This is 6,000, and also this side it is also 6,000. 6,000 from center to center. Now we have, how much is this? We got our size, square size of the column head to be 880 mm. So that means your this is a 6,000 6,000. So this was your column head, square size of the column head. So the size we got it to be 880. This one is 880. If I take the pencil again, this portion from here to here, this one is how much? This much is 880. This one, the square size of the column head, 880. This one was your how much? This one was your column strip, which was this total. This total, this one, the column strip, this column strip was how much? 3,000. So we got our this column head size, square size to be 880. Now what is our ln? Ln was from the face to face direction, this one. Ln is a clear span extending from face to face of columns or capitals. Capitals means nothing but this one. The column with head is called your capital. So this is how much now? This is 880. So half of 880, it will be 440. So that means your this 6,000 face to face distance means what? Or from the column head it will go. That means this column head, this one, and this one, this face to face distance is nothing but your ln. So what we can do, we can subtract this 6,000, this from the 6,000, this portion and this portion from the center of this column to the head of the column head, we can subtract this two, and this is nothing but how much? 880. So half of 880 and half of 880 is nothing but 880. You can directly subtract it from 6,000. So that is why ln is what? Ln is your this one. Ln is your 6,000 minus 880 by 2, 880 by 2. That means nothing but 6,000 minus 880. You can directly subtract. So it is how much? Your ln is 5120. That means your this distance is, yeah, let me show you. From this to this face, this face to face is how much? This one. 5120. 5120. So we got our ln value. Once we got our ln value, we can calculate our moment. This one mo wln by 8. So wln by 8, ln is this one. W was w into L2 into ln. So W was our 18. Total factor load we had calculated 18. This one, total factored load 18. Then we have L2 or L1, it is both same, and L is also same. So 6,000, 6 meter, all this sizes are same. 6,000, and ln we have already calculated F120 square. Okay, so we got our moment to be this much. Okay, fine. This is done. So now if we go to the next step and remove all this, now once we know the moment, we can calculate our reinforcements. How much reinforcement area of total area of reinforcement is to be provided? We already know for the moment. This is our moment. There is no longer span or shorter span in this particular question. So this is your moment. Width of the column strip we have calculated it to be 3,000. Middle strip is also 3,000. Okay, so for the negative moment, our and the positive moment, negative moment, we have what? Mu, the ultimate moment we can calculate. The ultimate moment will be, we know from where this 65, 75, 0.75, 0.65 have come. We already know these things from the IS codes. This moment has to be multiplied. Yes. So this moment has to be multiplied. 0.65% is to be distributed, and 0.75% is to be resisted. Here it should be designed in such a way that 75% is resisted. So similarly for the positive, we know it is 0.35 is to be distributed, the positive moment. 60% is to be resisted. It must be designed in such a way. So if we have multiplied it with by the moment, so we got our middle strip will be how much? For the negative moment we already know 0.65, but since 75% it is designed in such a way so the 75% is already resisted, so we subtract here this design moment 172.526. Okay, in the similar manner we calculate these things. Then we can calculate this percentage of steel, 50 FCK by Fy whole into 1 minus root over 4.6 mu by FCK BD square. Okay, so B we already know it is 3000. FCK we know 20, Fy we know how much, Mu we have calculated for each this thing. Then we have, once we know the percentage of steels, we can calculate the total AST. Yes, total AST. Okay, what was that? This percentage of steel into BD. Okay, so in this way, like in the previous question we had calculated, like the same way we can calculate. So you can give me your attendance now. Enrollment 1. 1,
Present, ma'am.
2,
Roll number 1.
2, 4, 5,
Present, ma'am.
okay, 6.
5.
Present, ma'am.
Okay, let me check one thing. Enrollment 9 is present because in the first class I have already taken till 23. I think I have taken the attendance. I'll give those. So enrollment 9 is he present? 9 Charmi Lalu. No. 19, 20,
Present, ma'am. 28.
20, 21, 23 is present.
Present, ma'am. 23.
24 present. 25, 26,
26 present, ma'am.
27, 30, 31, 32, 34,
Present, miss.
36,
34.
okay, 36,
36 present, ma'am.
37, 38, 39,
39 present, ma'am.
42,
42 present, ma'am.
43, 45,
45 present, ma'am.
46, 48, 49,
Present, ma'am. 49.
50,
Present, ma'am. 50.
51,
51 present.
54,
Present, ma'am. 54.
55, 56, 57, Abdul Latif 57, 60, 61, 63,
Yes,
97,
ma'am.
Yes, present, ma'am. 61.
61
Ma'am,
present,
61 present.
yeah,
Ma'am,
Yes.
60 present, 60.
60 present, okay. 99, Nanzia present. 101,
Yes, ma'am.
24, 104,
104 present, ma'am.
106, 106, 108, 109, 100,
109 present, ma'am.
okay, 111,
Present, ma'am.
okay, 113,
111.
Present, ma'am.
120,
113.
114, 18,
Present, ma'am. 114.
okay, 18,
Present, ma'am. 113.
20, 24,
110.
Yes,
33,
ma'am.
Present, ma'am. 133.
34,
130.
36,
136 present, ma'am.
136 present, 43,
Present, ma'am. 143.
44, 45,
145 present, ma'am.
45,
Present, present.
48,
present.
49, 149, 150, 151. I'll give you in the group the absentees. If anybody is present from there, you can uh, inform in the group. Okay. Others, anybody? Now you can say if you can. 9 absent, 19 absent, 21